Okay, so welcome to lesson 16. So today we are going to be doing more angle work and hopefully moving on to circles, which is going to be this lesson and then the next lesson, which actually won't be in 2 weeks' time because we're stopping for Christmas. It will be in 4 weeks' time. So plenty of time between now and then to get ready for a really big lesson on circles, because I'm going to give you a task to practice all your circle parts before then. But for today, I want to continue our work on angles in polygons, which we did last time. We started last time. I want to introduce a little bit about circle parts and angles in circles. And I'm going to really focus today on exam style questions. I know that a lot of you are sort of getting closer to those exams and are hopefully starting to work on lots of past exam questions. And that really is the best technique now for your revision. So, and just practicing and getting ready. So I'm going to do that as we go through today and just focus quite a lot on past exam questions. But before we do that, I just wanted to do this, okay? So we learned about angles in parallel lines last time. And you can see here that I've actually got some lines that look parallel, but we do not know at the moment whether they're parallel, okay? Without doing some maths, I don't know whether they're parallel. And that's because there's no arrows on them. So remember how I said that if there are arrows drawn on the lines like this, then we know those lines are parallel and we can say, okay, well, I can work out some angles. I can do things with this. But actually the arrows weren't there, okay? So instead, we're going to work backwards. We're going to use these angles to decide whether or not the lines are parallel. So I'm hoping you can remember the rules from last time. And bonus points if you can put in the chat the name of the parallel line rule that you would need to use for this one. Those bonus points are just extra smiles from me, okay? Are these lines parallel? So yes or no. And what I'm going to do is I've given you a little poll, so I'm going to have a look at that. Think about the maths you need to do. Refresh your memory from 2 weeks ago. And then tell me, do you think the lines are parallel or not? Go for yes, parallel, or no, not parallel. If you're not sure, have a guess. Doesn't matter if you're wrong. It really doesn't. Think about what you can do with those angles. Do some maths with them and think, oh, does that seem like they're parallel? Oh, great. Excellent. Lots of people have answered. And lots of people have told me that, yes, they are parallel. So fantastic. Okay. So 100% of you there saying they're parallel, which is perfectly correct. Okay. And hopefully, no one's put in the chat the reason, but if anyone wants to write the reason, the actual mathematical reason for them being parallel, there were words we learned last time. I'll give you, it was either corresponding, alternate, or co-interior. Those were your three. So if you want to write which one it was, go for it. Don't worry if you can't remember, but you do need to learn those words. And hopefully what you did is you just did 143 plus 37 is equal to 180. So if these angles add up to 180, then they are parallel. So yes is correct. And someone's written in the chat corresponding angles, which isn't technically the one we use because corresponding angles are the equal ones where they're like that. So if I had given you 143 and 143, yes, you would have used corresponding angles. Instead, we were using the ones where we add up the two angles inside that C shape, which is the co-interior angles, okay? So that's the mathematical word you were looking for, co-interior there, okay? Or sometimes allied, but generally co-interior, okay? Let's try again. Actually the same, it's a co-interior again. So have a go. Do you think these are parallel or not? And I'm going to give you a chance to vote on that. If yes, you can write the reason. If no, you can write the reason. Pop it in the chat if you're feeling. Oh, brilliant. I just saw someone had written co-interior. Well done, Tamitha. Excellent job. And again, excellent. Okay, correct answers coming through from everybody. Yes, and thank you for putting that in the chat as well, Meadow. Yeah, the correct answer is that they are not parallel because they do not add up to 180. So these lines might look parallel, but in an exam, if you said these were parallel lines, you would be wrong, okay? Because these two numbers do not add up to 180. So well done. They are not parallel. 100% correct again. They're doing really, really well with this. Let's continue. Let's do a couple more of these. Okay, so we're not looking at co-interior this time. We need to think a little bit further ahead than that. So are these parallel, yes or no? And if you can put a reason in the chat, that's even better. I'm going to give you a chance to vote for yes or no. So parallel or not parallel. Should be, there you go. Some people answered. Oh, another person's answered. I'm going to give you another 10 seconds. Oh, we've got a split decision today on this one. We've got some people saying parallel, some people saying not parallel. So I'm going to go through that very quickly. So let's have a look at what we know. But a few things we could look at here. We cannot get a direct answer from those two angles because they don't fit that criteria. They don't fit the alternates. We're just going to grab a highlighter, if I can remember how to do a highlighter. There we go. Alternate would have been if it was inside those Z angles like that. It's not alternate. We can't use that, okay? Can't use corresponding either at the moment. We could have, if we had, say, that one, we could have used corresponding, but we can't use that. And obviously we can't use co-interior. So we have to do something else. And there's a few options you've actually got. You could use vertically opposite angles. And vertically opposite angles are equal, which shows that that is 80. Or you could use your straight line rule, and straight lines on it, or angles on a straight line, add up to 180. So that's 100. And so on. There's plenty, or we could have used it there as well. That's 100. So you can see now that these are 100 and these are 80. But this one is 110, okay? So they are not the same there. The corresponding angles are not the same there. So no, these are not parallel. So well done to the 67% of you that said that they are not parallel. Really, really good job. Well done. Okay. And let's clear my, okay. That was the end of that. So that was a reminder of last, the sort of parallel lines work we did last time. And also really important, just a reminder that if lines look parallel but don't have arrows on, they may not be parallel, okay? So you've got to really be aware of that. Right, we did some work on interior angles and polygons. So we did quite a lot on interior angles, the interior angles being the ones inside. So for example, interior angles of a triangle add up to 180, of a quadrilateral 360, of a pentagon was 520, I think. Oh gosh, 5 something anyway. 540, sorry, and so on. So you have to do some maths for that. Now, exterior angles and polygons are a little bit easier to deal with, okay? Because exterior angles are formed by just extending the side onwards. So they're not actually this whole, and this is really important, an exterior angle is not this whole thing outside the angle. It's actually only the part of the angle that's formed by extending a side onwards, okay? So that is what is called the exterior angle. So there's a couple of things that we can look at, and exterior angles are actually a lot easier to work with than interior angles because of the fact that they're only these extensions of the lines. They're not the full thing, makes it really easy to work with them. And the easiest thing to work with these is that the sum of the exterior angles, okay, think about what would happen if you were to say, take a walk around the outside of this, this triangle here. Okay, so imagine this is a park and the sides of the triangle are a path, like going around the park. And you're just going to go for a walk around it and think, you're going to start here and you're going to walk along here. And then you get to this point and you turn and you go this way and you turn and you go this way. So you've walked around, and although you've walked in a triangle, you've technically done a full circle. Okay. So you've technically kind of walked in a full circle. So the angle that you would have turned with your body is the same as the angle in a circle. It's the same as 360 degrees. So one of the most important things that you need to remember about angles in a polygon is that the sum of the exterior angles in a polygon is 360 degrees. And that's really, really useful because it does not matter how many sides the polygon has. So we could imagine that this is a pentagon. It's got 5 sides, and the exterior angles, you can see they've all been sort of drawn on for you. So these lines have been extended out. But imagine this is a pentagon shaped park and you're going for a walk around this path. The same thing would happen. You'd go for a walk, you'd turn a little bit, you'd go for a walk. Your body will have turned one full circle whilst you've done that walk. So even though this has got 5 sides, its exterior angles are still the same, still add up to 360 degrees. Okay. And it doesn't matter how many sides a polygon has, the exterior angles are always going to add up to 360 degrees. And that's really useful because we also have this little useful piece of information. The sum of the interior and exterior angles at each vertex. Vertex is the mathematical word for corner. So at any corner of the polygon, the sum of the angles, the interior plus the exterior, are 180. So all that work we did last time on finding the sum of the interior angles and then using it to find like individual angles, that is really useful. You have to know that because if you have an irregular polygon, that's the only method. So you do have to know that. But when it comes to having a regular polygon, like here, we've got a regular 9-sided polygon, actually using the exterior angles makes finding the interior angles much easier. It's much quicker to find the exterior angle first. Let me show you on this one. I'm going to show you before we do this question. So I'm just going to show you like randomly over here. I'm going to extend this side here out, and I'm going to find the side of the size of one exterior angle on this 9-sided polygon. So it's got 9 sides, and then that means it's got 9 exterior angles. Okay, I'm not going to draw them all on, but it's got 9 exterior angles, and you can see that each one of those angles makes up part of a circle. And if I put them all together, they would make up a full circle. Okay, so I would technically have 9 equal angles making up a full circle. And so the sum of those exterior angles is going to be equal to 360 degrees. And that means I could call like one of them X, so they'd all be the same. So they'd all be X. So that means that all 9 of those X's is going to be equal to 360 degrees. So one individual angle, remember a regular polygon means the angles are all the same size. So one individual angle is going to be 360 degrees divided by 9, which is 40 degrees. Okay, so that tells us that each individual angle, exterior angle, is equal to 40 degrees. Okay, so last week or 2 weeks ago, we did some work where we learned how to find the interior angles, where we had to think about how many triangles there are in there. Do you remember? There's always going to be n minus 2 triangles times by 180. So n in this example is 9. So it's going to be 180 times 9 minus 2, which is 7 times 180. And 7 times 180 is 1,000 260. So these interior angles, so this plus this plus this plus this and so on, they all add up to 1,260. They're all equal again because it's a regular polygon, so we can divide that by 9 and we do get 140. That's the method that we learned last week. I've gone through it very quickly because we did a lot of work on it last week. But you can see here that by using this exterior angle method and subtracting, so saying, okay, well, I know that they all add up to 360. I know that there's 9 of them and they're all the same. So 360 divided by 9 is 40. And then I know that these two are on a straight line. So they have to add up to 180. So I know if this is 40, this has to be 140 and so on. Okay. So that simply makes it it's an easier method and it always works for your regular polygons. So it's just kind of a quicker method of doing that. Does anyone have any questions on that before I move on? I'm actually going to answer this question now, but I just want to check if anyone has any questions on finding exterior angles. Does that make sense? Did I go through it quite quickly? Okay. No questions coming up, then so I'm seeing some nods. So let's have a look at doing this question now. So we've done part of it anyway. Right. I'll leave that exterior angle on. So the vertices B and E are joined with a straight line. So we've got regular 9-sided polygon, straight line here, okay? And then work out the size of angles B, E, F. So B, E, F. So working out the size of this angle here, okay, is going to be, so we're going to have to think about what the whole interior angle is. So that's where you're going to use your angle knowledge to find, either go through that long method to find the interior, or you could think, okay, well, if I can work out the exterior, so we know that's 40, I can work out the interior, that's going to be 140, okay? So I can work out this whole angle. But I only actually want B to E to F. Remember, if you're asked to find the size of an angle and you're given the 3 letters of the angle, the one in the middle is the one at the point of the angle. So it's this angle here that we're going to find, okay? I'm going to highlight it quickly just because it's easier to see. We're looking for that angle there. So looking for that angle, we know that this whole angle here is 140. And another thing we know about this is that these lines here, because this is a regular, what's called a nonagon, okay? These lines are all going to be parallel. So we can put parallel on there and there, okay? So because we know that, we can also use, we could extend this out, okay? And we could say, well, if this bit, can you see there? This angle here is going to be 40. Okay, so we can see that that bit there's 40. And can you remember we did the parallel lines last time? We've just done a practice on them, a reminder. That shows us then that we have got F angles. Could anyone give me the correct mathematical term? Someone's already said it today, for those F angles on parallel lines there. And tell me how I would know, how I would use them to find out what this angle that I need here is. Great, they are corresponding, correct, well done. How do I use them? What do I know about corresponding angles? How do I use them to find out what BED is? Or just tell me what BED is if you prefer. Anyone want to have a guess at what BED is? we've got 40 here, and their corresponding angles. Corresponding angles are equal, so BED has to be 40 as well. Okay, so that shows us that if that bit's 40, that whole bit is getting very messy now. So I'm just going to do some neaten some things up a little bit. So what did we know? We knew that this whole thing here was 140 and this little bit here was 40. So that tells us the angle BFE. And I tend to write angle like that is equal to 100 degrees. Okay, so quite a lot going on there, but hopefully that's really helped you to see how using exterior angles has made that finding that 140 easier there. Okay. I'm going to do a couple more examples of these past exam questions because I just want you to get an idea for kind of how to go about answering these questions. Sometimes they can kind of look a bit daunting, but quite often once you start filling angles in and start just sort of putting all the information that you know on there, then you'll find that you quite quickly kind of get to where you need to get to. So let's have a look here. We've got a diagram that shows a regular hexagon, okay, and a regular octagon. You should know how many sides they have. If you don't, it doesn't matter, just count them, okay? The diagram is right there, so let's have a look. The hexagon, 1, 2, 3, 4, 5, 6, okay? So 6 sides and they are all equal. So I've put these kind of equal sides sign, like little dashes, just to remind myself that they're all the same. And here I've got an octagon, 1, 2, 3, 4, 5, 6, 7, 8. Should be 8 sides on there, okay? Again, all equal. So I've got these two and I'm looking to calculate this angle X. Now you'll notice that this angle X is made up of a couple of angles that I can find quite easily by just splitting this line straight down the middle. If I just split this line straight down the middle here, I've actually got 2 angles. I've got the exterior angle of this hexagon. You can see how this line is being carried on out. So I've got that one. And I've got an exterior angle of an octagon. Okay, I might do them in 2 different colors just to make that clearer. So let's put that one in red. Okay, so I could add those 2 angles together to get the total there. So let's do the exterior angle of the hexagon first. So that's 6 sides. So remember, exterior angles always add up to 360. And they're all the same. That one is the same as this one. It's the same as this one. Okay, they're all the same. So that means that it's 360 divided by 6, which is 36 divided by 6 is 6. So 60 degrees. So that means that that bit there is 60 degrees. So that was the hexagon. The octagon, the exterior angle of the octagon. Okay, once again, doesn't matter that there's a different number of sides. They still add up to 360 degrees. Okay, there's just more of them now. There's 8 of them rather than 6 of them. So this one is going to be 360 degrees divided by 8. And 360 degrees divided by 8 is 45 degrees. I don't know why I did that the other way around, but 45 degrees there. Okay, so this here is 45 degrees. Okay, so now I can just find my total, and my total is simply going to be those 2 angles added together. So the total value of X equals 60 plus 45, which is 105 degrees. Okay, so you can see how using the exterior angles there made that question really quick. We could have done it using the method that we learned last week. We could have done this all by using the interior only method but it would have taken longer. So I could have found the interior angle of the regular hexagon. I could have found the interior angles of the regular octagon. I know that that's that and that's that, and I could have subtracted from the 360. I would have got the same answer, but it would have probably taken that little bit longer because I would have had to do all of those formulae to get there. So that exterior angle has really helped me get to that answer much quicker. Okay, before I move on, I've talked a lot. Does anyone have any questions? I feel like I've been talking at you a lot today. Oh, have I frozen as well? It's just the video. Oh, I don't know if you're still there. Just give me a second. I'm having a few technical issues. Sorry, everybody. Okay, give me a nod if you can see me. Oh, yay. Okay, great. We are back. Thank you. I'm sorry if I froze. I hope you didn't miss too much. Do let me know if I've stopped. I think my internet's been a bit not the best today. Okay, I'm gonna skip that one for now. I will do this question actually, because this is quite a good question. So these are quite common questions that you do get. And the reason you just get part of the polygon, okay? So what it's saying here is RS and ST are two sides of a regular 12-sided polygon. So they've not drawn the whole thing. It's actually quite hard to draw a regular 12-sided polygon, okay? But they've just told you that there's two sides of it. And now the word regular is really important. If you see that and you've only got two sides, the first thing I'd recommend you do is you actually draw on the little dashes so that you know, because regular means that they're the same length or the same sides, okay? So you can put equal sides on there. All right. And you've got RT is the A diagonal of the polygon. So there we go there, okay? We are asked to work out the size of angle STR. So once again, start at S, follow it along to T, and then down to R. We're asked to work out the size of this angle here. So I'm going to call that angle X there. Okay. So can anyone tell me what type of triangle this is? We've got to consider the polygon, the 12-sided polygon. We also have to consider that triangle. What type of triangle is it? Which type of angles they are. Yeah, there are a lot of different names for types of angles. Which do you mean on parallel lines, or do you mean in the polygons, or just all of it? Sorry, just had someone saying that it's a bit confusing to know which types of angles. A lot of it is just learning. It's almost like making yourself flashcards and just sort of going over those flashcards again and again. So on parallel lines, you've got those, you've just got to really remind yourself by practicing. So you've got ones that look like this, they're on alternate sides of the line, okay? So I remember those just by thinking that they're alternating the sides of the line. So if I know that if this angle is given and this angle is X and this angle is given as 70, I know that X equals 70 because I know they're the same because they're alternate angles, and so on. If I've got one that looks like this, but the angles are there, these are on the same side. They're corresponding because they're on the same side of the parallel lines. So if this is 70 and this is X, I know now that X is 70 because they're on the same side and they're in the same place. They actually look exactly the same, don't they? If I slide the angle down, the line down. So yeah, so in answer to your question, I think mostly it is just kind of get yourself some flashcards, write them out, practice, just sort of, it's like a memory thing. I'm afraid you have to just really practice learning those names. They are quite important. Has that, I don't know if that's helped. I'll try and find some sort of, I've got like probably some flashcard style resources. So I'll try and find some and get them sent out for over the Christmas. You can have a Christmas holiday practice of just sort of revising them and going over them. Going back to this, so there's no parallel lines in this question, actually. This is only to do with the triangles and the polygons. Almost, Tabitha, thank you for answering my question. It's not equilateral. I think it's very unlikely equilateral. This is actually going to be long. The only two sides that we know are the same are these. So it's got two equal sides and one longer side. So it's actually an isosceles triangle. So well done. Okay. So if I've got an isosceles triangle, another thing that I can do, and I'll do it pretty quickly, is I'll say to myself, this is also the same. And this, like being able to sort of see a triangle and go, oh, I've been told that those two are the same. Okay. I know that because they're the two sides of a regular polygon. They're the same. So because they're the same, I now know that the angles at the base of them are the same because it's created this isosceles triangle. So I've created an isosceles triangle. I've got two equal base angles and I've got two equal sides. Really important from the next lesson we do on circle theorems. This is also going to be something that you'll be doing a lot. So always look out for equal sides, always look out for equal angles. Okay, so I know that this is X and I know that this is X and I need to find out what X is. What can I do to find out what X is? What angle can I find out? Put the name in the chat, put the name of the angle that I can work out for me. Excellent. Perfect. Yeah, I can work out RST. Good. If I can work out RST and I know that those two are the same, I can work out the value of X. Okay. Now there's two methods I can use. I could use, in fact, I might do both methods just so you can see. I could use interior angles, a little bit longer, I think, but some people just prefer it. Or I could use exterior angles. They will both give me, hopefully, the correct answer. Interior angles is the method that we learned last time. So last week, we learned the method where we have to use that formula. And the formula is n minus 2 times 180. Okay, that gives us the sum of the angles. And remember, this is a regular one. So we only want one of the angles. So we can actually divide that by the number of sides there are. So I can use that formula, which I don't think is given to you in the exam. I'll double check that, but I don't think it is. I think you have to remember it. Or you can just use exterior angles, which to me is more kind of just remembering a method. So some people prefer to remember a formula. Some people just prefer to remember a method. Okay. For me, I'm more about the method, but it's up to you. So let's have a look at doing this formula method. Okay, so we have got n. Well, we're told it's a 12-sided polygon, so n is just 12. So it's 12 minus 2 times 180. Technically, just finding out how many triangles are in there. Okay, and then divide it by 12. So 12 minus 2 is 10. 10 times 180 is 1,800. Divide that by 12 is, I don't know. Oh, 150. There we go. Okay. And so that tells us that this angle RST is 150 degrees. Okay. So it's not too hard. If you can remember the formula, it's actually very easy. You can always just plug in the number of sides and you can get that. Okay. Remember, this formula works for regular ones. Okay. But this part of it works for any whether it's regular or not. Okay, let's think about just method 2, if you'd rather use the exterior angles method. So we're going to get the same answer, hopefully. Method 2 is finding this out first. What's the exterior angle? So the exterior angles all add up to 360. There's 12 of them, so we divide it by 12. 360, 30 divided by 12 is 3, so 360 divided by 12 is 30. So that bit's 30. And then remember, the interior angle is equal to 180 minus the exterior angle, which is 180 minus 30, which is 150. Okay, so 2 methods giving us the same answer. Okay, and hopefully you can kind of see that they both lead to the same answer. You can just choose which one you like best and use that in the exam. So if we know that these 3 angles are in a triangle, they add up to 180 degrees. And then we also know that x plus x, x and x are the same. These 2 angles are the same. We could actually say, well, x plus x. Oh, my pen just broke a second on me. X plus 150 equals 180. 2x then, you know how I love to write an equation. Plus 150 is 180. So x is going to be equal to 180 minus 150, which is 30. I should have put 2x there, shouldn't I? And then x is going to be equal to 30 divided by 2, which is 15. Okay. So 180 minus 150 divided by 2. Quite a lot there. There was quite a lot in that question. Does anyone have any parts that they would like me to go over again, or any bits of that question that they weren't sure about? Is it okay? Okay, good. Okay, great. Thank you. Right, bearings then. So let's do a quick bearings. Bearings are just quick because we've done a lot of maths. So I just thought, let's just do some bearings. Still angles, but just more of a sort of navigation tool. There's 3 things that you need to know and to remember for your GCSE about bearings, okay? Bearings are a measure of direction. They're basically what anyone people use out at sea, sailors use. They're used in air traffic control to give direction. So it's your compass points essentially, okay, where we're talking on a map. They're always taken from the same direction. Does anyone want to guess in the chat? What direction do you think bearings will be taken from? If you're looking at a map, where do you kind of find first on the map? North. Excellent. Well done. Well done, Tabitha. Correct. So you're going to find north first. Then they always are measured in the same direction. Which direction do you think they are measured in? There are 2 possible directions for angles. You can go clockwise or you can go anti-clockwise. Well done, Tabitha. Clockwise direction. And then bearings are always written in 3 figures. Okay, that was harder to guess because you didn't know that. So they're always written in 3 figures, even if the bearing is like 8. Okay, so if you're going from north, that's my bad north line, and you're literally measuring a bearing of 8, which will be really, really close to north, just like that. Okay, it would be written as 0, 0, 8, like that. Okay, I should have done 7, shouldn't I, just to get some James Bond in. But always measured and always written in 3 figures. Okay, so those are your 3 things that you need to know about bearings. So with directions, there are all of these compass points. Hopefully you know them, and if you don't, you do need to learn them for your GCSE. Okay, so we've got north, east, south and west. Never eat shredded wheat is how I remember it. I love shredded wheat though, so and then in between those at equal places, equal spacings, northeast, southeast, southwest and northwest. And the bearing of north, there are actually 2 bearings for north. There is 0, 0, 0, or it could be 360, but we tend to just use 0, 0, 0 for that one. Bearing of east, then it's an exact right angle turn, so it's 90 degrees. South from, remember, we're not going from east, we're going back to north, and then we're measuring all the way around to the south. So south is at a bearing of 180. West is at a bearing of 270 because we had to go back to the north again and measure all the way around. You might think, well, it's easier just to go that way. It is easier to go anti-clockwise, but bearings are always measured in the clockwise direction. So we have to go all the way around like that, okay? Even if you wanted to take the bearing there, you couldn't turn that way. You would have to turn all the way around that way and take that full bearing there. So it would be about 350 degrees, okay? So always going clockwise. So I think now we've got back to our north. So we've got back to our 360 there, okay? 360 and 000 are the same thing, okay? So they're the same bearing there. They're both just representing north. And then northeast. Northeast is exactly halfway between north and east. So it's at 045. Southeast is at 135. Southwest is at 225. And northwest is at 315. So you've got to get kind of good at adding 45 degrees on if you're trying to work out the bearing of southwest. You've got to go, okay, well, southwest is going to be 45 degrees from south. So I've got to add on 45 to 180 and so on. Okay. Some exam questions will use west, for example, instead of a bearing of 270. So do be aware that if you see an exam question that says a ship travels west for 5 kilometers, then you know that it's going on a bearing of 270. Okay, so you do want to know these. And because you want to know these, I thought we could do a quick multiple choice question. We'll do them really quickly. Okay, so if I'm facing north, I hope you can see this okay, and turn clockwise, what angle do I need to turn? 2 point east. So if I'm facing north and I'm turning down to the east, is it going to be A, 270, B, 180, C, 90, or D, 45? I just need to change that. And what is it going to be? Brilliant. Really, really quickly and 100% correct. Well done. It was C, 90 degrees. Fabulous. Okay, same question. From the north, turning clockwise, what angle do I need to turn? 2 point south. I'm going to do this really fast. Is it A, 50, B, 180, C, 100, or D, 90? Okay, brilliant. Really quick. Just nice. 100% correct. Well done. It was B, 180 degrees. Okay, same question, but this time west. Is it A, 90, B, 75, C, 300, or D, 270? Super fast. Just waiting for one more person. Okay, I'm going to stop at that. Well done. Correct. 100% correct. Well done. It was 270 degrees for that one. Northeast. Same question, but for northeast. Tiny bit more to think about here. Is it going to be A, 45, B, 35, C, 40, or D, 90? And once again, and really quickly answered 100% correct. Fabulous. Everyone who answered got it correct. Okay. And I think that is at the end of that. One more, southwest. What is southwest going to be? Is southwest going to be A, 150, B, 225, C, 270, or D, 180? Oh, still really quick. A little bit more thinking to do, a little bit more maths. So we're going from north, and we're turning all the way around to the southwest. I'll give you a clue, it's more than 180 degrees. And well done. Okay, great, well done. So everyone again who answered got it correct. It was actually 180 plus that extra 45, so it's 225. Right, so past exam questions with bearings. Now, we can't do too much of this without, piece of paper, ruler, and all of that. But I wanted to just give you an idea of what bearings questions look like. So here we have a scale and a diagram. So one of the first things you'd have to do is you'd have to get your ruler out and you'd have to measure this, okay? You want to measure it perfectly accurately. You don't want to lose marks for things like that. If you did that, I can tell you that on this exam, the ruler will have measured that as 7 centimeters. So I'm going to just tell you that because obviously we don't have a ruler right now. So part A, work out the real distance between L and H. We're told that 1 centimeter represents 5 kilometers. So if 1 centimeter equals 5 kilometers, then 7 centimeters is going to be 5 times 7 kilometers, which is 35 kilometers. So that is your part A, 35 kilometers there. Okay. Right. Part B, now you need to get your protractor out to measure the bearing of H from L. And the reason why the thing that I want you to really think about here is of H from L. So your protractor goes at the place where the bearing is measured from, okay? So you're measuring from L, you put that middle part of your protractor on there, and then you line up the north line, and then you measure it around. So do have a practice at this. It's not that easy to show you without a protractor, but do make sure you practice using your protractor. This bearing, I believe, should be 110 degrees. You can go back to your knowledge. We've just done that. So I know that you know your kind of rough angles. I know that you know that east is 90, okay? I know that you know that south is 180. So you know that that's going to be about 110. If you've measured it wrong and you've measured 70 there, that can't be right, okay? It does say that it's not drawn to scale, but generally they're kind of roughly how they should be. You've measured it and it's coming up as like 300 and something. It's definitely not right. You can see that that angle is between 90 and 180. So it's about 110 is about right. So use your kind of estimating, but do measure it accurately. And then part C, a boat B is 20 kilometers from H on a bearing of 040. So now we're going to go to from H, okay? So now I need to put my protractor at H. I need to once again line my north lines up. And I once again want to get that angle of 40 degrees. So I know my angle of 40 degrees is going about that way. That might be a little bit big, but there we go. So I've drawn my line of 40 degrees and I want my boat to be 20 kilometers away. So if 1 centimeter is equal to 5 kilometers, 20 kilometers, we're dividing by 5 there, aren't we? So we're going to divide by 5. So it's going to be equal to 4 centimeters there. Okay, so to go that way, divide by 5. To go this way, divide by 5. Okay, so I would need to draw 4 centimeters of that line, nicely neat with a ruler, put my cross, and that is where my boat B is. Okay, so they're quite nice, those questions. Just read them really carefully, look out for that word from, and just accurate measuring. As practice using your ruler and your protractor and everything before you go into the exam. Make sure you're confident with it, okay? Any questions on bearings? Oh, there's one other bearing thing I wanted to show you actually before we move on. Was there any questions so far though? Nothing. Okay. So the other thing that I wanted to show you, this is a not Earlier I did say that that drawing wouldn't be to scale, but of course it is to scale because that's a measuring one. Okay, so measuring, when you're asked to measure something, it is to scale. So you can look at it and you can guess. Okay, you can totally look at this and you can say that's somewhere between 90 and 180, closer to 90 than 180. I'm expecting it to be about 110. If I get an answer of 300, I know it's definitely wrong. Okay, so you can look at these, and if you're asked to measure things, you can definitely guess. When you see this not to scale, then guessing is not going to help, and measuring is definitely not going to help. Guessing might still help a bit, but measuring is like a big no-no. Okay, so it's saying to you not to scale is saying basically put your protractor away. You've got to do some maths here. You're not doing your measuring. Okay, so that's a really important thing to look out for. So what we're saying is the bearing of P from B. So the bearing of this angle from here is 102. Find the bearing of B from P. Now, the most important thing that you can do with bearings like this, where you have to do some calculations, is remember that when you draw the north line, if you're a bit neater than me, and you will be because you'll have your ruler, maybe I can do it like this. When you draw a north line, using your ruler, note how you've got these two arrows. They are parallel lines, okay? They are both facing north. They must both be parallel. And that is really useful information because we can use our angles on parallel lines to find these missing angles. So I can instantly say by corresponding angles that this and this must be the same. They must be 102 by these corresponding angles I've used, okay? I also, I'm just going to read the question, find the bearing of B from P. So P, here's P from P. All bearings are always measured from the north. So I've drawn my north line. They're always measured clockwise. The bearing that I actually want to get is this angle here. Okay, it goes all the way around like this. So it's this 102, and also is going to be this, should be a straight line, angle here on the straight line, so 180. Okay, so I can use that parallel line bit of information, they're corresponding, and I can add it to the 180, and I can say that the bearing is going to be 180 plus 102, which is going to be 282 degrees. Okay, so bearings and angles in parallel lines go very, very closely together. So that's why I wanted to put that in to today's lesson. Okay, any more questions? Or are there any questions? Didn't get too many questions. All right. The last thing I wanted to do today was just an introduction to circles and angles in circles. The main thing that I want is to make sure that when you join me in 4 weeks' time, because we're having a session, missing a session over Christmas. Merry Christmas to everybody, by the way. When you come back, I would really like it that you have familiarized yourself completely with all of the names of all the circle parts, because we're going to do circle theorems next. Okay. Circle theorems appear in both foundation higher, but only a few of them are in the foundation. But you do need to know all of these names of the circle parts. Do you know all the names of the circle parts? Sure? Because I'm going to start next session with multiple choice questions. So you can prove that to me at the beginning of the next session, okay? So do just take, you can pretty much just Google names of circle parts, or actually this is taken straight from the cloud port. Circumference is the line around the outside. Diameter is the line straight across the middle. Radius is the middle center to the circumference. Chord cuts any or joins any 2 points on the circumference. Segment, tangent, and sector. What do they all mean? What are those words? Make sure you know them, because we're going to dive straight into circle theorems next time. Okay. Now I'm going to stop there because I won't go on to testing you on those until next time. So I'll stop the recording, and then if anyone's got any questions, you can